Talk about multiplying and dividing rational expressions. We'll go through several examples of it and talk about the process. The first will be multiplication, a little bit easier. And really there's three basic steps for this. Step one, just like with the other, is to factor completely. Okay, so you want to factor your numerators, factor your denominators. And then the nice thing with multiplying rational expressions is when you multiply two fractions, you just multiply across the numerators and across the denominators. So we can combine these all into one single fraction anytime you see that multiplication symbol. So when we look to factor this, we'll just work with each part individually. So if we start in the numerator of the first fraction, can we factor this expression? We have a leading coefficient of 1, so we're probably looking for binomial factors. Are there two factors of -2 whose sum is positive 1? Positive 2 and negative 1. Okay, so you can, again, reverse FOIL. In the denominator, what common factor can we remove? Remove a 4x squared. When you remove that 4x squared, you're left with what is your first term? Just an x, and your second term will be a -3. Okay, now because we're multiplying these fractions, we can just extend our fraction bar across here, treat it all as just one common fraction. How can you factor the numerator of this second fraction? Remove a common factor of 2x, and that leaves x plus 1. And in the denominator, we have the difference of squares, so we can factor it into the sum and difference of terms. The terms being squared are x and 1, so it's the sum of them and the difference of them. Okay, so again, that's your step 1. Step 2 is to cancel any common factors. And so here as you go through, there's no x plus 2's, x minus 1's can cancel. This 2 cancels with the 4, leaving a 2. This x cancels with one of these x's, leaving an x. And the x plus 1's can cancel as well. So this allows you to rewrite your solution, or simplified form. You have an x plus 2 in the numerator. That's the only factor. And in the denominator, you have a 2, and you have an x, and you have an x minus 3. Right? And just like the last section, once you simplify all of this, you do have to take into consideration any domain restrictions. So you're going to identify domain restrictions. That aren't apparent in the simplified form. So when you look at this, basically what you're looking to do is see, were there any factors that got canceled from the denominator? So here, even though one of these x's got canceled, there's still a base x. We have this x minus 3, that stays. Okay, but here's a factor, and here's a factor that got canceled from the denominator. We have to account for the fact that this expression cannot be divided by 0. So we need to put those restrictions. So x can't be a -1 or a +1. We have to include those domain restrictions. And now x can't be 0 and x can't be 3 either. And so if I ask you to identify the domain restrictions for this problem, the answer would be x is all real numbers except for 0, 3, -1, +1. So there's 4 domain restrictions, but when you write out your domain restrictions, you only need to write the ones that aren't apparent from the simplified form. All right, what I'd like you to do is on page 32, I want you to quickly answer question number 3, sample problem 3. All right, if we take a look at this problem. Okay, step 1, look to factor everything completely. So our numerator is has binomial factors, the leading coefficient of 1, so we're looking at x and x. What two factors of positive 12 have a sum of negative 7? Negative 3, negative 4. Our denominator is the difference of two squares, so it factors into the sum and difference of the bases being squared. The bases being squared are x and 3. We take the sum times the difference. Again, because we're multiplying here, we can just extend this into one single fraction. What common factor can we remove from each of the terms in this numerator? We take out an x to begin with, leaving x squared minus 6x plus 9. So we have this x. This trinomial has a specific pattern. It's perfect square at the beginning and end. So this is the base x squared, this is the base 3 squared. If you take that product and double it, you get the middle term. So it's a binomial square pattern. So the two bases x and 3 with the sign of the middle term is your factor pattern. Okay, so here's all of our numerator. Oops. These should have been written up here. All right, so here's all of our numerator. As we continue moving into the denominator, what common factor can we remove from these terms? Take an x squared, leaving an x minus 4 would be our factors in the denominator. Okay, step 1 is complete. We factored everything completely. There's no other factors that we can remove here. So now we look to cancel any common factors. So the x minus 3's cancel, x minus 4's cancel, this x cancels with one of these. Nothing else cancels. So we get along our top just an x minus 3 squared. And in the denominator we have an x, we have an x plus 3, and those are all of our factors. Okay, so here's our simplified form. You don't need to and you shouldn't put it into a polynomial form, just leave it as factors. Okay, now we can go back in and look to see, are there any factors that will cancel from the denominator? Here's one, and here's one. We need to restrict those zeros or those values. So x can't be a 3. Is that shown in our simplified form? No. So we need to exclude that. X can't be a 3. We also see x can't be a 4. Is that shown in our simplified form here? No. So we need to exclude that one as well. Okay, so this would be the complete answer, okay, with the restrictions as well.